Thank you for joining Cosmos DB Conf. In this session, I'll talk about architecture patterns of Azure Cosmos DB and Azure Synapse Analytics. My name is Hiroyuki Nakazato, Cloud Solution Architect, Data and Analytics, working for Microsoft Japan. This is agenda. First, I'll show technical overview for Synapse Analytics, Synapse Link for Cosmos DB, and Cosmos DB change feed. Next, I'll take about 5 architecture patterns with Cosmos DB change feed and Synapse Link for Cosmos DB. Third agenda, I'll introduce a new preview feature, custom partitioning. Next, I'll do demos and finally discuss about ideas for when to use which architecture pattern. Azure Synapse Analytics is the first unified cloud-native platform for converged analytics. Synapse Studio provides a unified experience for developers by allowing them to perform all analysis operations through a single UI. Synapse Analytics originally included two analytical runtimes, SQL and Apache Spark. Recently, Data Explorer has been added as a preview feature. So Synapse Analytics now covers data warehousing, data engineering, as well as near real-time data usage scenarios. Azure Synapse Link for Azure Cosmos DB is a cloud-native hybrid transactional and analytical processing, aka HTAP capability, that enables near real-time analytics over operational data in Azure Cosmos DB. Operational data is stored in Cosmos DB transactional store, which is row store optimized for transactional operations. Data in transactional store is automatically synchronized to analytical store in near real time. No ETL is required. Analytical store is column store optimized for analytical queries. You can access analytical store with Synapse Spark Pool and Synapse Serverless SQL Pool. Access to analytical store does not affect transactional store. In other words, you can analyze Cosmos DB data without worrying about request units. You can activate Synapse Link for newly created SQL API and MongoDB API containers. With the March 2022 update, you can now activate Synapse Link for existing Cosmos DB SQL API containers. For existing MongoDB API containers is on roadmap. Change feed in Azure Cosmos DB is a persistent record of changes to a container in the order they occur. Change feed can be handled by Azure Functions and Azure Stream Analytics and many other services. With March 2022 update, Mapping Data Flow, the low-code, no-code ETL feature of Data Factory and Synapse Analytics is also be able to handle change feed. Now I will talk about 5 architecture patterns. The first pattern is the combination of Cosmos DB change feed and mapping data flow. Mapping data flow is available in both Data Factory and Synapse Analytics. Mapping data flow reads the data from Cosmos DB change feed, transforms the data, and outputs it to the data store. Mapping data flow supports over 15 data stores, including Cosmos DB, Azure SQL, PostgreSQL, and so on. The second pattern is the near real-time analytics using Synapse Link for Cosmos DB. This pattern uses Synapse Serverless SQL Pool and Power BI. The arrows in the diagram show the flow of data. Source data is stored in transactional store of Cosmos DB and automatically synchronized to analytical store. Serverless SQL Pool can recognize the data in analytical store as SQL views. The metadata is managed by SQL database in Synapse Workspace. Serverless SQL Pool can be accessed from Power BI via the connector for Azure SQL database. Both direct query and import mode are available. Based on requests from Power BI, Synapse Serverless SQL Pool reads data from Analytical Store using queries and returns the results to Power BI. One of the largest benefits is that all services are serverless, so it's appropriate for small start. Serverless SQL pool is pay as you go based on scan size, so there is no charge if there is no access at all. The third pattern is an evolution of the second pattern. You may want to use Synapse Serverless SQL pool to perform large-scale aggregation of data in Cosmos DB Analytical Store. If it's one time, not a problem. However, if you aggregate the data frequently, performance and cost may become problems. In such case, it's recommended that you aggregate the data on regular basis. If you prefer code-based approach, it's good to use Synapse Spark Pool. As shown in the diagram, Synapse Spark Pool reads data from Cosmos DB Analytical Store and uses Spark's parallel distributed processing mechanism to process the data with high throughput. Spark Pool can output results into data lake storage, and serverless SQL Pool can read the data. The fourth pattern is almost identical to the third pattern. The only difference is this uses Synapse Mapping Data Flow as ETL feature. If you prefer low-code, no-code approach, it's good to choose this pattern. The last pattern is cost-effective archival of historical data. Transactional store and analytical store can have mutually independent TTL. Analytical store's storage pricing is lower than transactional store's one. It enables to achieve cost-effective archival of historical data. If transaction store's TTL, aka TTL, less equals than analytical store's TTL, aka ATTL, items in transactional store are deleted before items in analytical store. If ATTL is -1, analytical store keeps all historical data. Before we talk about a new preview feature, custom partitioning, let's talk about concepts of partitioning and partition pruning. In general, partitioning and partition pruning is very important to improve the efficiency of reading data using Apache Spark. Partitioning is to separate directories to store data according to the value of fields that frequently specified in query filter conditions. And partition pruning is to avoid reading unnecessary partition data in query, so query become more efficient. This is example. There are data named example logs in ADLS Gen 2, and example logs are partitioned by event year and event month. We read the data using Spark SQL. This SQL specifies that event year is 2022 and event month is 02. As a result, this SQL reads only the data in the partition with a blue box. This is partition pruning. As a note, analytical store is not partitioned by default, so partition pruning is not available by default. Custom partitioning enables to output data from analytical store partitioned by specified fields to Azure Data Lake Storage Gen 2 using Synapse Spark. ADLS Gen 2 is a primary storage account linked to Synapse Workspace. The benefits are reduced data scanning from partition pruning and query performance improvements. When to use? If you have a high volume of update or delete operation and or slow data ingestion. In the viewpoint of pricing, the following two costs are required in addition to analytical store. The first is the cost of computing Synapse Spark to process custom partitioning. The other is ADS Gen 2 cost that store custom partitioned data. There are current limitations. It's only available for Synapse Spark, and it's also only available for Cosmos DB SQL API. Custom partitioning can only point to the primary storage account linked to Synapse Workspace. There are related docs with custom partitioning. If you are interested in the feature, please read them. Now let's move to demo section. I will give 4 demos. First, let me give you a demo about Cosmos DB change feed with Synapse Mapping Data Flow. Let's check the details of the data in Cosmos DB Data Explorer. We use the Cosmos DB database. The name is IoT Demo DB, and the container, the name is Raspberry logs for the demos. This container has data from a simulated IoT device that measures temperature and humidity. The data keeps coming in the container. The partition key for the container is event date hour, and each item has properties such as event date, event hour, temperature, and humidity. Next, let's move to Synapse Studio. Here, what you can see is the mapping data flow that processes Cosmos DB change feed. Each box on the mapping data flow canvas is called a transformation. Different types of transformations are available, and you can combine these transformations to create a code-free pipeline for data processing. Mapping data flow runs in Apache Spark cluster, so it can handle big data. Let's look at the source transformation for the input data. In the source settings tab, we point to the dataset for the Cosmos DB container described earlier. The source options tab contains important settings. By checking the change feed checkbox, the mapping data flow will handle the change feed of the Cosmos DB container. If start from beginning is checked, you will get initial load of full snapshot data in the first run, followed by capturing changed data in next runs. If include system columns is checked, the mapping data flow will import the system columns of the item. ID property will also be included in the system columns, so check this if you need ID. By turning on data flow debug is checked, you can see the results of each transformation in the data preview tab. Let's take a quick look. We can see event date hour, event date, event hour, and temperature, humidity, and system columns, including ID. Mapping data flow basically ends with a sync transformation that outputs the data to a data store. Mapping data flow currently supports more than 15 data stores. This sync transformation outputs data to a table in Azure SQL database. In the Mapping tab, I have defined which properties of the Cosmos DB container are put into which columns of the SQL database table. I've also defined the nested JSON in Cosmos DB should be flattened and stored in SQL database table. Due to the limited time of the session, the mapping data flow has already been executed. So let's look at the SQL database table where the results of the mapping data flow are stored. The results of mapping data flow are stored in a table named dbo.raspberry.logs. Execute a simple select statement to retrieve top 1,000 records. Now you can see that the Cosmos DB items has been inserted into SQL database table. Let's move to second demo. The second demo is near real-time analytics with Synapse Serverless SQL Pool and Power BI. We use the same Cosmos DB container as input. The Cosmos DB container has Azure Synapse Link enabled. So let's move to Synapse Studio. This is a SQL script that accesses the Cosmos DB Analytical Store. The connector to property in the upper middle is built in. This indicates the query uses Synapse Serverless SQL Pool as query engine. First, execute a simple select statement to retrieve the first 10 records against Cosmos DB Analytical Store. We use open set function and specify the Cosmos DB account name, database, region, account key, and container name to this function. We can get the results in tabular form, and we can see the results contain event hour, message ID, some system properties, and other properties. It's not secure and time consuming to specify the connection information, including the account key to open set each time. So we will register Analytical Store as a SQL view, which requires creating the database first. This database is only for managing metadata, such as view definitions. The actual data is stored in Analytical Store. After creating the database, switch the database with a use statement. Then execute a create credential statement with the account key as a secret. This is the last step. Create a view specifying last pi row logs as the view name. Specify the open set function in the from clause to specify the account name, database, and container, but for the account key, specify the credential name we just created. Let's run some queries on the view we have created. Execute a simple select top 10. The same results are returned as in the first select statement. Then applying another select count statement. There are there are over 18,000 records in the Analytical Store. Now I'm opening Power BI report. Now let's see how it looks in the Power BI report. You can see Power BI reports without leaving Synapse Studio. In the field section on the right side, you can see Power BI recognizes the columns in the view we just created. This report displays the number of logs, the stats of humidity and the temperature. This report connects to Synapse Serverless SQL pool via SQL database connector with direct query mode. So behind the scenes of the report, the query is being executed in Serverless SQL pool. Serverless SQL pool is scan size based pricing. So if the data size or number of users is small, the price is much lower. It's perfect for small start. Next demo. The third demo is code-free data processing with Synapse Mapping Data Flow. The previous report will work fine if the data size is small. However, if the data size is become bigger, the scan size will be bigger, resulting in higher price and processing time. Therefore, it's better to aggregate data in advance. Here is a notebook for Synapse Spark Pool. We will create a database and a table to access Cosmos DB Analytical Store from Synapse Spark Pool and Mapping Data Flow. In the first cell, create a database to manage metadata. And in the second cell, create a table. When creating the table, we specify cosmos.olap in the using clause and link to service and container as required options. The link to service represents the connection to the Cosmos DB database. The created tables can be accessed using Spark SQL. If you prefer code-based ETL, you can continue to work with Spark Notebook. Here, we will try the code-free style. This is the mapping data flow for data aggregation for Cosmos DB Analytical Store. In the source transformation, specify workspace DB as source type and specify the database and the table we just created. Mapping data flow can now handle Cosmos DB Analytical Store as a source. The next step is to perform the desired aggregation processing. In this demo, we will aggregate the data by event date and event hour, and produce hourly count, stats of humidity and temperature using the aggregate transformation. We output the results as Parquet files into Azure Data Lake Storage Gen 2. The Parquet is in a column-oriented format optimized for analysis. Here is the Synapse Serverless SQL script for aggregated data. First, execute a simple select statement to retrieve the first 10 records. We specify the path for data lake storage and Parquet as format to the open row set of the statement. Then we can get the results. Next, switch database with use statement and create a view for the aggregated data. Now we can access aggregated data with simple SQL statement. As you can see, we are able to get information aggregated by event date and event hour. The other Power BI report is almost the same as before, but serverless SQL pool behind the scene is reading aggregated data. So the scan size is smaller and we can expect smaller price and smaller processing time. If your data is growing rapidly, it's good to use Synapse Spark or Mapping Data Flow for periodic aggregation for quick querying and report rendering. Next is the final demo. It's custom partitioning. It's for custom partitioning. This is a Synapse Spark notebook for custom partitioning. The first cell triggers custom partitioning job. We specify required options. In the line number 3, specify the link to service. The line number 4 is Cosmos DB container. In the line number 6, specify event date and event hour as custom partition keys. The base path in line number 7 represents the path from the root of the primary ADS gen to container linked to the Synapse workspace. We will show you the results of this custom partitioning job in storage browser. This is a primary ADS gen to container. We can see the directories MNT, Cosmos DB partition store, which are specified as the base path for the custom partitioning job. This is the directory has Cosmos DB account name. This is the directory corresponding to the Cosmos DB database. And these are the directories corresponding to the containers. Here is a directory with the name partition equals event date, event hour. There are directories for each event dates, and we can see directories for each event hours. We can find the Parquet files with snappy compression in the bottom directory. Let's go back to Synapse Studio. In this cell, we execute a query with custom partition store. Same to the cell above, specify the link to service, container, partition keys, and base path. Filter the data frame by event date. Then partition pruning is performed, and unnecessary partition reads are skipped behind the scene. Of course, it's possible to specify multiple partition keys using AND keyword like this cell. We can access custom partitioned stores using Spark SQL. First, create a database for the meta store and create a table. When, when creating the table, specify the linked service, container, partition keys, and the base path. Now we can access the table with a simple query that specifies custom partition keys in the where clause, like this cell. This is all for my demo. Let's go back to the deck. As a summary, I will talk about ideas for when to use which architecture pattern. The first pattern, if you'd like to process change feed with low code, no code style, and or don't want to or cannot use Synapse Link for Cosmos DB. If you want to process data with shorter latency than Synapse Link for Cosmos DB. The second pattern, this is appropriate for near real-time analytics Cosmos DB data. It's free serverless BI and cost-effective due to pay-as-you-go pricing based on data volume and query scan volume. The third pattern, if you have large volume of data, which should be aggregated for BI and analytics workload, it's good to use this pattern with pattern 2 and custom partitioning. The fourth pattern is similar with pattern 3. If you prefer low code, no code style, it's good to use this. The final one, if we want to remove data from transactional store but want to retain read-only copy cost effectively, this is all for my session. Have a nice journey with the rest of Cosmos DB Conf. Thank you so much. Bye.